Welcome, I'm Mike, a Googler, a statistician, and I'm passionate about learning and sharing. Today, I'm a friend, and I welcome you into my office. This is a series of end-to-end workflows using Vertex AI on Google Cloud to do machine learning operations. Each one of the workflows is presented as a Jupyter notebook inside of a GitHub repository. If you've been following along, what we've done is we've set up an environment and we've set up a data source, and each one of these picks up that data and carries it through the entire process from training a model, or maybe even preparing the data and then training a model, evaluating that model, deploying that model for online predictions, and then various other tasks around that ecosystem as the videos progress. Let's jump over to the GitHub repository, take a look at it, and just recap where we're at, because this is the beginning of what we're calling the O3 series. This is going to focus on using BigQuery's built-in machine learning. We'll talk more about that as we get going here. So this is the repository page. As we scroll down, we see all these notebooks. We see the intro. You probably started with this intro video. Let's first cover an overview of this repository and look at where we're at in the map. So as we zoom in on this, we first covered the O2 series, which was using AutoML, an automated way of taking data, doing machine learning, and then getting a final model. In this case, we're going to pick a model type. We could actually still use AutoML for this series, but I'm going to shift gears to we're directing the type of training to do. This is going to require code. That's an interesting topic. We'll get into more details on that. We're still going to work from a Vertex AI Workbench Jupyter Lab instance. We could do this all within BigQuery, and we'll talk later about whether we want to work from Python or work directly from BigQuery, and what are the pros and cons of those depending on your project. In this case, we are going to take this really fast treadmill through the process where we use inside BigQuery the ability to train, evaluate, and even create predictions and explanations, all from data without ever leaving BigQuery. The language of BigQuery is SQL. So today we're going to write a lot of SQL. Even when we're in Python, we're going to write SQL that runs in BigQuery. I'm kind of excited about this one because to me, this is one of those areas where it just opens up this field to so many people. And this even opens up more than just building a model, but actually using a model to a very large field. I worked in this area for a very long time, and I've seen products try to take models and put them next to databases or on run times next to them, and build scores. And I always think that's just so complex. And here, we're just going to call a SQL function and make predictions happen. I'm excited. Let's try to tone that down a little bit. Hang around. In the next video, we'll even talk about, well, what happens when we actually want to make that model available for app mod, developing an app. We can actually take it out, make it portable, and we're going to go use it over in Vertex AI in the next video. So that's our summary. Let's zoom back out here and let's talk about how we got here. We, in our very first video in the series, set up a Google Cloud environment. If you did that, then just keep following along here. If you didn't, you have a choice. Stop, go back, watch those, and jump in and run these alongside us. Or you can just click the O3A notebook here and follow along today with this video. Let's get straight into our content. We are going to go to Google Cloud. So open a new tab. Go to console.cloud.google.com. This wants me to authenticate. Now that we're in our console area, we want to go to Vertex AI to get to our workbench. That's a Jupyter Lab instance that we've set up. I'm going to go to the menu here and click on Vertex. And we'll even take the fast path straight to workbenches. In my case, I've chosen a user managed workbench. That means, it's up and running as long as I've left it on. There are managed notebooks that only run when you're using them. They'll automatically shut down. They'll even automatically scale up and down, saving that for a future video. But in this user managed notebook called My Notebooks, we're going to open it. It's a Jupyter lab at that point. And in the world of data science and machine learning, we're probably all familiar with this one. As we jump into that, in the setup video, we also clone the GitHub repository directly in here, which means there's a copy of it there. We don't need this widget that it's telling us about. We want to go to today's video, the O3A notebook. Let's double click that. And we are in. So you are watching the video that is linked right here at the top of the notebook. Might seem a little weird to have a recording of a video that you're going to watch and see the recording in the video. But once you're into this, first thing we want to know is, what is the prerequisite for this? Well, we're going to need our data in BigQuery, and we did that back in the O1 video as part of, first 0.0 video, we set up the environment. The O1, we set up the data, and the only prerequisite you need is to go back to the data source. A little overview of what we're going to do. We can skip that and go to the picture version. In the world of Vertex AI, you get lots of components that enable you to do what we're calling these fingerprints of machine learning operations. Today, we're going to take a very small topography over this space. We're using our notebook, but we're going to go interact with BigQuery. We could actually skip the notebook and do all of this in BigQuery because the language of everything here is SQL. I prefer to do it from a notebook to kind of illustrate almost two workflows in parallel. One is this interactive coding experiment, but also the ability to use Jupyter to use tools that I'm familiar with from Python. We'll also go take a look at it in BigQuery. So that makes this a very small path. Notebook, here's the notebook instance, and there's BigQuery. Let's get going. The first thing we want to do is run our setup parameters. The only one of these we need to change is what we named our project when we set this up. And for the videos, I've been using project demo 3 or statmic-demo 3. I set up parameters for various things like the region, so I can just reuse that, not have to change it throughout my code. The project ID, data name, we've been using this fraud data set we'll talk about again. This notebook, I use that as a parameter to label any assets we create to separate them from all the other workflows. We have a variable that's holding our target variable for the model we want to train, and that's from the credit card transaction data. It's the column called class that just has two values, a value of 1 if it's a fraudulent transaction and a value of 0 if it's not fraudulent. And we know from that O1 video, there's a lot of not fraudulent. There's just a handful or a couple of hundred of the actual fraudulent transactions. And when we get to build that model, we might want to omit some columns. We're using a prepared data set from that O1 video that I included a column that I created that has transaction ID, so I could identify a row uniquely. You don't need that for training. If you train a model with that and it were useful to the model, it would be useless to prediction because the transaction ID is never going to happen again. So we'll set these parameters. We want to import the BigQuery client so we can interact with BigQuery. And let's go ahead and once we've imported that module, let's instantiate a client for BigQuery just named BigQuery. All right, jumping right along, this is going to be a fun one. We want to train a model. We are going to use a data set that's in BigQuery, and we're going to send SQL commands to BigQuery that basically say, take that data, train a model with it, store it under a name. Let's walk through SQL. SQL is one of my favorite languages. It allows me to do so many data exploration and data prep steps and bringing together multiple sources into one place. And just the data engineering side is so important to making a good model that we should probably even just do video series on why you need to be an expert at understanding and manipulating and creating data sources in order to be a really good modeler. Right here, our very first thing is we're going to define a string that's our query that we're going to ship over to BigQuery. And then we're going to create a job that goes to BigQuery and runs that string that's our query. It kind of sends over the text and runs it as an operation. And then at the end, it'll let us know when it's done. Now, what is this operation going to do? If you're used to SQL, you're used to things like select columns or star for all columns from a data set. Sometimes you want to store those in like a table, and you'll start first with the create statement, create table. Or you might even say, well, maybe that table already exists. Create or replace table name as select information from some other table. We're going to do a model almost identically. We're going to create or replace, if it already exists, a model instead of a table, and we're going to give it a name. And BigQuery names have those three levels. There's the project, there's the data set, and then there's the asset name. Assets before this video we've called tables. In this case, our asset is going to be a model. So we have the project, and that would be, well, in this case, we're assuming, since we're already in the project in BigQuery, the project level's there. We could type it in. It's not, you can always include it, but sometimes you can omit it. We could type project ID here. And then we're going to go into the data set called fraud. And then we're going to create a model called fraud_LR. LR for, I'm picking a model type here. I'm going to pick logistic regression. That's kind of a bread and butter model. If you're in like neural nets, you could even pick like an activation function of sigmoid. And if your target is class 0, 1, you're essentially doing logistic regression. I have a whole video series planned on that kind of information. In this case, we're going to use just the traditional inferential way of, kind of taking, an X matrix that's got columns of features and rows of observations, and use linear algebra to calculate a model from a data set. In this case, logistic regression is specified by going into an options command or an option statement in our SQL, and we give it parameters for this. The model type is logistic regression. Auto class weights of true. Input label columns. Well, there's one label column. A label column in BigQuery is the target. So that's that variable I stored above. I'm bringing it down into the code here. A data split column. Well, BigQuery's model here, they have the ability for you to let it split the data. And you could give ratios, but we have a column in our data, and we want to use it. So we're going to use a splitting method of custom in a data split column called custom splits. Now, that's not what we named it. We named it splits. I'm going to create custom splits from splits here in a second, lower in the code. Notice that these options are set, and then I do a select star, except any of the columns I want to omit, so transaction ID. That's kind of pausing on SQL. I love the except, because so often you don't want everything. But the list of things you do want is long, and you don't really want to type it out. So you could say select everything, but omit a few. So it kind of takes care of that case where you want most columns, but not all. It's easier to write a short list of exceptions. We're going to select everything except what was an omit, so transaction ID and the splits column. We're going to do that by selecting from the prep dataset, fraud_prep, that we made back in the 0, 1 video. And we're going to only select rows where the splits is not equal to test. So we're going to get both the validation and the training data. Now, let's talk more about that custom splits column. I use a case statement to create it. And the case is, well, when splits is train, okay, then false, else true. All right, that's interesting. I'm setting it to say false for train, otherwise true. That is counterintuitive. You would almost want to say, well, true, you want to use the training data. False, you don't want to use the non-training data to make this custom splits. Let's talk a little bit about why this is an important thing. This is why we have to read the manual. We have a new API. We have machine learning with BigQuery. It's in SQL. It has parameters. We need to understand those parameters so we can implement our method in that data source. So what I'm going to do is click this link that I've dropped in here and talk about custom splits. So we can go in, it's got a nice manual. These are hyperlinked. We can say, well, we want to do a data split method of custom, a data split column. Notice the language here. This identifies the column used to split the data. This column cannot be used as a feature or label. Cool, we know that. And will be excluded from the features automatically. Awesome. When the value of the data split method is custom, the corresponding column should be of type bool, so true or false. The rows with true or null values are used as evaluation data. Rows with false are used as training data. Okay, remember, false is training. The rest of them, true, are going to be used as evaluation. Now let's go back and reinterpret my case statement. I'm going to get everything except test data from my pre-made splits column. That means I have two levels. I have validation and training. Well, when splits is equal to train, it's false. Those will be used for train. Everything else, so the validation, will be labeled as true, and it'll be used for evaluation. Okay, so the reason why I spent a little time describing that is that's a little confusing. Like I had to learn that when I first used this, but the cool part is across BigQuery ML, there's lots of other algorithms. We'll talk about those at the end of the video. You can now know the logic of that parameter. All right, let's run that. And what I probably should have done is set that to run and then described what was going, because it runs about 6 minutes to build this model. If you watch the O2 series, AutoML, we gave that a budget of an hour and it tried lots of methods. Logistic regression was probably one of them since it's a classification model. In this case, we're directing it to this one specific method, and we're even kind of fencing it in to how it uses that method. Just these columns with just these rows of data. That's kind of this deterministic way of go calculate an answer. If you look at the theory behind regression-based models, there's these great theorems like Gauss-Markov where particular matrix algebra gives you the optimal answer that minimizes the errors, the misclassifications for that set of input data. So you can kind of just go calculate these. You don't have to necessarily do a search for the answer in a space. You can kind of calculate the answer in a space. And that's what this model is going to go away and do. Now what I'm going to do is go to the title screen, pause the video for a moment, and come right back right after this is done running, and we'll continue through. So in the magic of YouTube video, this will only be a few seconds for you. All right, our model's done running. Let's go back and take a look at that. What we see is that it finished running. The next cell, what I'm going to do is that job ran and it came back with some properties attached to it. Some of those properties are like start time and end time. I can subtract those, convert it to seconds, and take a look at the runtime. I see it ran for 171 seconds. I'm pretty bad at arithmetic, so let's divide that by 60. And that's about 2.8 minutes, not very long. And I might want to look at things like, well, the model ran and it did have iterations. There is a loss function, and each step, each iteration that it goes through, it's still trying to minimize that loss function. Let's see what it was doing. I have a command where I can actually, again in SQL, say go to BigQuery, run a query, select star from. Okay, well, what am I gonna select from to get machine learning training info? Well, there's a function, ML, machine learning, dot training info. Okay, well that has an input where I have to give it a model name. Well, we just created a model. We give it that model's name, and we want to sort the list that we're gonna get back by iteration. We'll turn that into a pandas data frame so we can look at it here in our notebook. What we see is it went through 8 iterations, starting 0, going up to 7. Started at a loss of 0.68. minimize, minimize, minimize down to 0.11. We can see the learning rate was actually changing as it went, and we can see the duration of each step. Hey, this is kind of like a real human learning. A little sidetrack here. At the beginning, it knows nothing, so it doesn't take very long to run an iteration and it learns something. But as it goes, it's incrementally harder to add more information to the brain there. It did have a stopping rule, so whatever happened in iteration number 8, index 7 here, is it decided, well, I can't improve any more than you're expecting me to, so I'll stop. At this point, we could go straight in and evaluate using code from Python. We could go fetch information from BigQuery and bring it back over here. We're going to do that. But before we do that, let's go over to BigQuery and actually take a look at what we just did. We can click the link here to get to the console for BigQuery, but yeah, we already have console open. Let's just go there and navigate our way to BigQuery. I have it pinned up at the top here. Now, once we're in BigQuery, we know its architecture is highest level project. We're in project StatMike Demo 3. Let's expand that. Second level is data set. We've made one called fraud we're working in. And this is interesting. In our previous videos, we're just working with data. So we have tables, fraud and fraud prepped, the input data, the prepared input data. We could click those and we were able to see information about them, like the schema, or even preview the table. And in this case, we created an asset that's a model, and it put it in a folder called models for us. Now we can expand that folder, and we'll actually see the name we gave it, fraud_LR for logistic regression. And when we click it, it gives us tons of information about the model. Like, instantaneously in front of us, we can see, hey, here's the name. It was created on this date. It'll never expire because I didn't set a parameter to create an expiration. Last modified, the region, the model type, logistic regression. You can imagine maybe you ran lots of different models against this data set. You're wanting to just evaluate them all. You could separate them out and see things about them. You could see the training data stored in a temporary training data table, the evaluation data, which was that validation set from our incoming data that was labeled as true, not false, stored there. We could see the options for training. Like, we didn't set many parameters in our SQL code. We briefly looked over here at the model create statement, and we see there are lots of things we can set, but when you don't set things, you get their defaults. Well, in the case of our model in BigQuery, we inherited defaults because we didn't override them. Maximum allowed iterations 20. We didn't reach 20. We know we hit 8. Actual iterations 8. Regularization, this ability to kind of learn, it's a good video we should make. It's this ability to learn how to ignore parameters that are non-influential or over-influential in a model building process. There are two types of regularization that are common in like logistic regression, and the L1 and L2. Both of these were set to a default. Early stopping, true. Well, it didn't go to 20, it stopped at 8. Minimum relative progress. So this is going to be one of those parameters that's telling it it's okay to stop because you didn't make any progress. Learning rate strategy, line search, calculate p-values, false. Data split method, custom. Well, we did override that part. All right, if we go into training of the model, it's already created graphs for us. Now, we've fetched the loss function over from code by running ml. I forget the name already. Let's flip over and see ml.traininginfo, and we fetched the information sorted by iteration. Well, here, without running any code, just clicking the model, I get visuals that give me the loss function. I see it decreasing and then starting to flatten. Therefore, it knew it could stop. And it made it below that threshold of 0.1 we were talking about, I believe. We see the duration of each iteration. We see the learning rate. If we didn't want to see it as a graph, we could get it as the table that we returned. I didn't have to write any code. I just literally ran a SQL command, got a model, and it's automatically giving me this info. This is a very good business tool and very good, starting point for, I know a good method, and BigQuery has that method. We'll talk about other methods it has. And I run it against my data, and 2 minutes and 50 seconds later, here I am. I can also evaluate the quality of that model. I get all the methods I'd expect from a classification model. We talked about these in depth in the O2 series running AutoML. Well, logistic regression has them also. We have things like precision and recall. Precision is that ability to predict a true that really is true. And recall is that ability to say, well, the truths that we had in the original data, did we actually label them as true? It's my summarization from them. The great part about this is they even have nice little question marks where you can get information about these statistics. If you're not, maybe you're new or maybe you're not as familiar with the terminology, you're still probably very intuitive about interpreting it. You just need that little trigger. These little question marks are great for that. In our case, this model isn't as good as the model we created with AutoML. That's okay. Positive class threshold, this is going to be that cutoff where it decides whether it is a high enough probability to classify it as that class, I believe. Let's move this up. I believe this is interactive too. Yeah, let's move this up to 0.5 if we can. And what we'll see is we look over at precision and recall. Okay, yeah, those are adjusting a little bit. If we look down at our confusion matrix, again, I don't really like percentages when I have imbalance, and we know fraud, there's a lot less 1 fraud, it is fraud versus 0 is not fraud. I like using the actual counts when I look at these tables. And what we see is this model is shifted a little differently than the AutoML model. If I look at the not fraud rows, most of them are classified or predicted to be not fraud. So those are true negatives. But I have some false positives, meaning 812 times I was alerted that something is predicted to be fraud. Again, I think this may have adjusted with the threshold. Let's play with it. Yeah, definitely in the case of a positive class threshold in this interface, play around with this to interpret the confusion matrix. When we were in AutoML, the confusion matrix was from the actual predictions using a threshold of 0.5. Here, whatever I've just set the threshold at, I see a lot of times I've alerted people to investigate fraud that isn't fraud. That feels bad. That has an organizational impact potentially. But on the other end, 41 times when it really was fraud, it caught it. And only 2 times did it miss it. That's a little better than what we saw in the AutoML model. So I've got a technique and I've used a bunch of defaults and I've got a decent first step. I would definitely try to improve on this model, but yeah, this isn't bad. I mean, for 2 minutes worth of effort, here we are. Now, I also have the schema of the model. It tells me things like it's going to have a field name called predicted class. It's going to have all these features that it's expecting. Why is that important? Well, one of the things you would want to do with a model is create predictions with it. Let's go back over to our code. Before we get to predictions, let's continue on and talk about how to evaluate this model from code. Like all those things we just looked at, those automated charts, those are information that we can actually request back from BigQuery about a model. That's great when you're working in another application. Maybe we even did what we do in O2C, create a Kubeflow pipeline. Actually, let's just go ahead and say, let's build an O3C in the future, which makes a pipeline out of this process. And let's look at the evaluation data and use it as a decision whether or not to move on to predictions. The way we would evaluate is we decide which of the data do we want to retrieve and ask for it. First thing I might want is that precision recall accuracy F1 log loss, area under the ROC curve. Okay, those were here under evaluation, right up at the top, under aggregate metrics. If I want those, I could say select, okay, the variable train as split and everything else from ml.evaluate. So the machine learning.evaluate, that's the unique thing here. And then I tell it what model. And I say select everything from the prep data where splits equal train. So I'm feeding it data, okay, feeding it a data source, all the training rows from the original training data to create evaluation metrics for, and I'm making a variable with the label train and storing it in split. And then I'm going to union that to another set of data where I put the label test in a variable called split, and I select all those evaluation metrics from the same data set, but only for the rows labeled test. So I'm essentially scoring the test rows and scoring the training rows, getting those evaluation metrics for them, and bringing them back in a little 2-row table and displaying it. So I run that query, and what do I see? For the test data, precision recall. For the training data, precision and recall. Now, why would you want to look at it separate for these? Well, this is one way you determine if your model generalizes well, is you look at it on the original training data and it has performance ability, and you hope to have very similar, if not the same, performance ability on your test data, that holdout sample that hasn't been involved in the training, so it's never seen it before. And if you get that similar ability to predict using metrics, then you know, hey, this model has, if I'm happy with it, it has a similar ability to behave the same way on data it's never seen before. So in this case, that actually is pretty true. It's pretty close. So if I were happy with its metrics, then I would say, let's deploy it because it looked good on a holdout sample. Maybe I want to look at that confusion matrix, the ability to classify the data for the same samples. Let's do that. Let's send a query where we say select everything from ml.confusionMatrix, handy name, give it the model, and feed it data. We're going to feed it all the training rows and get a confusion matrix. This actually returns the counts, so we don't have to convert percentages to counts here. That'll run, and when it's done, we see that same little issue is, there's a lot of training data. The majority of the times when it was fraud, it said it was fraud and it missed 36 and got 360 right. Great. The alarming part of this particular model is of the non-fraudulent rows, the vast majority are classified as non-fraudulent, but 3,883 times it triggered me to think something was fraud that isn't. That's a lot of potential work from organizations. So that's where I probably want to improve this model. We could look at the same information for the validation set. Remember, that was about 10% of the data back in the O1 video. Same behavior. It's very good at finding the true labels, but it's also pretty bad at creating these false positives. We can look at the same thing for the test data, and we'll see the same pattern for that 10% of the data. Now at this point, let's say, this model it's at least going to catch fraud. Like, this is something maybe my organization doesn't have at all. And I go, well, while I work on it more, I do want to deploy this model and use it to, predict fraud and start getting labels and at least do something about fraud. I want predictions on new transactions. Well, I don't have any new transactions, so I'm going to reuse the same ones, but how would I create predictions from them? Well, right here in this section, we have code. We have a SQL statement that is going to create predictions for us from our model. Like, we haven't left BigQuery. We created a model. We've evaluated the model both visually in the interface and with code, SQL. Now we're going to use SQL to say, give me predictions. I smile because of how hard this has been in earlier parts of my career with databases where we try to do this. And here, it's like, we call it 5 lines of SQL, but you could write this as 1 line and it would still not even do a word wrap on the screen. Select everything from ml.predict. That's a predictable name for it. Name the model. Select star from the input data where splits equal test. So I'm going to grab the test set and score it. Now notice in this case, I didn't even exclude the transaction ID. BigQuery will even ignore columns that it doesn't need for the model. So I run this, bring it back to the data frame. Let's look at the column names that it has in that data that it brought back. Cool. And the next thing I could do is I could extract some of the columns and print them out very nicely in a data frame. So I'm going to take this prediction response, this data frame of predictions, and I'm going to use the head function to get just the first 5 rows by default. And I'm going to say, give me the splits. I want to make sure it was test data. That's what I asked for. Give me predicted probabilities and give me the predicted class and the actual class. So we can compare them. What I see is for these 5 rows, the actual class is 0. It got all 5 of them right. It predicted them as 0. And the predicted probabilities for label 1 was a probability of this, and hidden in that little dictionary there, and the way it's printed out is the probability of class 0. Now, this is a nested dictionary because BigQuery has these great data structures that allow these fields to have multiple values like an array, or even nested values like nested pieces. I want to extract that multi-informational cell back and pick it apart into its pieces. Because notice, it was long, it didn't fit in our screen there. So what I'm going to do is run this piece of code and then talk about what it's doing. It's going in and it's using a Python lambda function to extract for each label in that little dictionary the value and print it out as key value pairs. So a label of 0 has a probability of 0.93 and a label of 1 has a probability of 0.06. So I've pulled apart that cell and made it nice and pretty to read here using just a little piece of Python. I can't overstate how big this one piece is. I know that the type of model and the customization of models that you might want to do if you're like a professional in this area, it might not be available in BigQuery, but just the ability to go from data, a couple of minutes model, predictions, all within the place that's housing the data is gold as far as just business value and time versus effort here. Now, there's also bonuses. We have a model, we have predictions. A big part of modern interpretation of both a prediction or a model are explanations. And models that you build in BigQuery, many of them have built-in explainability data. And in this case, we've done a logistic regression model. We can actually ask for explanations. Let's take a look at that and then describe what they are. We can do select everything from ml.explain prediction, give it our model, and then give it a data set. And we'll feed it the test data again from the original data source. And we're going to even give it a struct that asks it for a value of one of its parameters. We're going to override a default, in other words. We're going to say give us 10 of your features for the top K features. So give me the explainability feature attributions for the top 10 values. We'll talk about what that means. Now, when I look at this data set, let's run that and take a look at it. what we get is a column of the predicted class, the probability associated with that class, which is always high, it's the predicted class, but we get these feature attributions. Now, what are feature attributions? Well, first, let's talk about the next column, baseline prediction value. When you build a model with training data, you could say, what's a baseline prediction? Well, if I went to every feature in the training data and took the middle value, and then plugged all the middle values into the model that I created, I would get a baseline prediction. What is middle value? Well, for a numeric feature, I take the median and I pick that middle out of the sort order. A mean wouldn't be good because it could be highly skewed due to like a lot of extreme values one direction or the other. If it's a categorical variable, then it would be like create a histogram and pick the tallest bar, the mode, and use that as the input for the baseline prediction. Now then, when you predict an individual row, it gets a different prediction than that baseline. And that delta can be attributed to the features in the model. Some features are going to play a bigger part in why that row's prediction, that transaction's prediction, is different than that baseline one, that middle one. That's a very handy piece of information. One, it could help you diagnose a weird prediction. Maybe you trained on a set of data, but when we train, we just have training data. In prediction world, we might get new observations with values that were never seen by the model. So it could give us a weird answer. We would be able to know which column, which feature is driving that particular prediction, which could help us uncover maybe why it's weird. It could also be handy for interpretation. Maybe this is fraud and we've gotten a value back where it classified as fraud. And we'd say, why do you think this transaction is fraudulent? Well, if it told me what columns drove the prediction, those columns have interpretations. In our case, the data set has been kind of made ambiguous by a transformation called principal component analysis, where it redimensionalized it. So we don't know what they mean. They did that on purpose to make the data public without giving out people's information. But inside that bank, they know what that parameter means. And it might be location of transaction. It might be age of account or number of transactions. That gives an investigator a path to chase to investigate why it might be called fraud. In the world of like credit reporting, you might think of being able to tell a person your score is this, and this is what drove it. That could help them know how they might make it better if they were trying to improve their credit score to get a loan approval. Those things sometimes are even mandated by law to be available to people. Here, we created a model and we automatically get this just with a line of SQL. So again, a great bonus of building this model here. Now, we want to see those feature attributions. Again, this is one of those cells in BigQuery that have multiple pieces of information that we can pull out. I'm going to go down that column. I'm going to write a little piece of Python code. Again, one of the reasons why I like using Python to interact with BigQuery is I want to graph this and I want to see it using tools that I'm familiar with. You may have different tools. I'm going to use matplotlib. I'm going to cycle through that column. I'm going to extract out the feature in the attribution values as pairs. And I'm going to put that in a pandas data frame and I'm going to make a picture of it. And that's what this cell does. And when I do that, I see for that first row, prediction, the index of the first row. It is primarily, let's take one look. The prediction value is larger, it's less negative than the baseline. So it's more positive. And when I see what's driving the more positive value is variable V11 or feature V11, V12, and V4. And at the same time, V14 is actually trying to drag it lower. That's where I would point my investigation if I were focusing in on this prediction to start with. Might not have all the information, but it's a good starting point. That made the data come alive at the prediction phase. That's the beauty of explainable AI and the easiness of getting that from BigQuery. All right, we are going to... our workflow is done for this one, but there's some questions I've left hanging as we've gone through this. So let's do a little Q&A. and cover some of those questions.
Hi Mike, why use BigQuery for ML?
So I've probably mentioned this multiple times as we've gone, but more people speak SQL than speak languages of machine learning. Your Pythons and then your APIs from Python, your TensorFlow, your scikit-learn, your PyTorch. Maybe a lot of us use Spark, and we have different tools in there that we use. But SQL opens this up to a much larger component of our business, more users. And also, it puts it in the hands of users who actually understand the data because they work with it every day. They use SQL to, prepare it and stage it and store it, make it useful for things like dashboarding or analysis for us or just driving the business. I think putting high-level tools in their hands is a good starting point, is a great way to create the conversation of machine learning and AI in the business and advance this field. Now, I built a model. It needed improvement, but it's still a good model. We can have a conversation. Maybe the person who built that didn't have the skill to identify or make it better, but they have a starting point. We're going to have a conversation that otherwise would not have existed. This transforms businesses. Never fear putting the tools in people's hands. Create those conversations and have them. Let's go to the next question.
Why did you choose to use Python clients for BigQuery work?
Because I like Python, and that's usually where I work from in most of my workflows. And that's kind of the point, is there are clients for many other areas. So I picked Python. You could pick C# or C++. Maybe you're building an application and you work from Node. Go for it. Work from your area, or if you're the SQL language speaker, work directly in BigQuery and don't even come over to a tool through a client like this. That is what I encourage people, because whatever language you're used to also has other tools. Like this graph I made at the end using Matplotlib. That was my preference, and I was able to very quickly take information and make it useful to me. I encourage, since BigQuery has so many clients, use them and then use those clients' ecosystems, those languages' ecosystems, to amplify this information and make it even more useful.
What else can we do with BQML?
All right, so I picked logistic regression, which, between linear and logistic regression, that kind of covers what most of us learn in that first course in statistics in college. You can do much more. This page is actually linked at the top of the notebook. It is my favorite page in the manual for BigQuery ML, BQML as it's affectionately called. It has the end-to-end user journey for each model type. Let me bring that screen up. If you go through these, you see, well, it gives you the ability to say, well, I'm going to create a model, or I'm going to use a model. Now, if I'm creating a model, I have different objectives. I could be trying to create predictions. So supervised learning, I have a column with numeric value. So I want to do like a regression-like approach, or I have a categorical column where I want to do like a classification kind of approach, and I want to try to predict that column. So these are supervised methods, and unsupervised is, well, I have lots of data and I want to redimensionalize it for purpose, whether to preserve as much information as possible but shrink it, or dimensionalize it and create clusters. So maybe I can look at groups of customers and approach them differently. That would be unsupervised learning. Maybe I have time-based rows where the rows are related in a time base, like days and months, weeks, quarters, and I want to say follow a value over that time and then project it out. So time series analysis. This, whatever my approach is, tells me model types and gives me a link to how to get the base code to create that model type. How do I do this particular actions associated with that model, whether it's processing the features, whether it's hyperparameter tuning for some model types where I actually want to not just build a model, but kind of optimize some of the selections I make in the model building process. We're going to cover that in a lot of future videos. Model weights, information. They even have tutorial links for using these if you want to just get an idea like how to get started. Like we're looking at a tutorial now. These are other tutorials to get you in. And then when it comes to using model, in our code, we saw ourselves use that ml.predict, ml.evaluate, ml.confusion matrix. Well, I could see here under supervised learning, I've got linear logistic regression has the ability to get all those. We could even retrieve the ROC curve. There's the ML predict. If I wanted explanations, there's explain_predict that we pulled back. This gives me like a little map. Like I open up the map and I want to go on my journey of what's available to me depending on the approach I'm taking. This list grows almost weekly or monthly with BigQuery, so keep revisiting this. All right, do we have any more questions? Let's look at this one.
What if I want online predictions within my application?
All right, so in our O2 series, we had an AutoML model and we put it at a Vertex AI endpoint so that we could kind of send a transaction to that endpoint and get back a grading, fraud or not fraud. Here, if the new transaction were in BigQuery, we could run ML predict and we would get those predictions. But what if in real time, we're trying to, as transactions, before they even land in a place like BigQuery, we want to pass them through an endpoint and get that score. Let's use Vertex AI. That's the next video, O3B, where we're going to take this model we built and we're going to put it over in Vertex AI as an endpoint, just a little bit of SQL code again, and get it over there and use it for online predictions. With that, you might be at this point going, hey, I would like more information about BigQuery. I'm going to link up here and down in the description over to the section of the O1 video where I went through a slide deck and I gave a brief introduction to what BigQuery is. Definitely click there and use that if you've gotten to this point and you're still kind of lost on that part. Go over there. I think that's like a 7-8 minute segment of that video and you can get a refresher or an intro to that piece. All right. With that, did you like this video? If you did, please press the like button. It lets me know, kind of like a pat on the back. It also helps other people discover it. Do you want more videos like this? Hit subscribe. It lets me know people are waiting. And if you click the bell, you'll get an alert when I do upload a video like this one. Did this help you? If it did, leave a comment below, even a short one, because videos of this length, if you're like me, you kind of read the comments before you commit to watching something this long. It helps others know if it's going to be valuable. So leave a little comment below. And most importantly, if you watch this and it triggered ideas for, hey, can this do this? Or I would like to see it do that. Those are other workflows. I want to add them. So there's that. Did you see me do something wrong and you want to correct me? Or did you see something where you know a better way? You want to inform me? The easiest way to do that is just go to the repository in GitHub. Again, that link is below if you didn't start from there. At the top of the repository, click the issues button, create a new issue, refer to this video. We'll start a conversation and we can almost, in real time collaborate and create an extension of that repository that's available to everyone immediately, much faster than I can remake this video. And with that, I want to say thank you for your time and your feedback. Let's work together to make the practice of AI and ML more collaborative, accurate, and approachable. Today we worked a lot on approachable. I love that. To a wider and well-connected audience. Thank you. Have a great day.